All right, we're going to talk about complex numbers today. So if you remember, complex number is, we give this I, where I is equal to the square root of -1, okay? And I squared is going to equal -1. So here, we just have a couple of quick examples of how to convert from a square root of a negative number to that I, okay? So anytime I have this, I'm actually going to pull this out into the square root of -1 times the actual number. So the square root of -1 is I, so this becomes I square roots of 7. So I'm going to pull out that -1, I have the square root of 16. So the square root of 16 is 4I. So a complex number is made up of two components. It's made up of a real portion or a real part, which is the A, and it's made up of the imaginary part, which is BI. And A and B have to be real numbers, okay? So most of the ones we're going to find are where A and B are actually integers, but they just have to be real numbers, okay? So we have addition, subtraction, multiplication of complex numbers. So when we're adding these in like terms. So I'm going to go 8 plus 3, which gives me 11. 6i plus 2i is 8i. And now subtraction. Subtraction is the same way. So I'm going to go 4 minus 6, which is -2. 5i minus a -3, which that's going to make it a plus 3i. So 5i plus 3i is 8i. Now this one's a little bit different because a lot of times we look at this and go, oh, hey, what if when I multiply these together, I'm going to get rid of that negative. But actually, you have to pull out that negative piece here. And we're going to look at this. So this becomes square root of -1 times square root of -1, which is actually -1. 4 times 5, which is -20. So be very careful when you multiply in these. So we want to make sure we pull out that I first, because this is really 4i times 5i, which would give us that -20. The last one is we're going to kind of talk about double distribute or FOIL. So what I'm going to do is I'm going to go 1 times 1 is 1. 1 times 3i is 3i. 2i times 1 is 2i. And then 2i times 3i is 6i squared. And I have 1 plus 5i plus 6i squared. Well, what is I squared? I squared, if you remember, was -1. So this becomes 1 plus 5i plus 6 times -1. So this is going to give me -5 plus 5i. All right. So we have this, let me kind of erase this to give my a little bit more room here. So now we have this idea that we know I is equal to the square root of -1. And we have I squared is equal to -1. Well, I cubed is equal to -i, because what that is -i squared times I, which is I cubed, right? This is -1, -1 times I. Now, if I have I to the 4th, that's 1. So now, anytime I have I to a power, I can reduce that down to one of these three things. So I'm either going to reduce it down to I, -1, -i, or 1. And the way I'm going to find out is I'm actually going to break this up. So I'm going to break this up. This is an odd number, so I know I need to take an I out. Okay? So I need to get this to be an even number. Now, if this even number is divisible by 4, so 36 is divisible by 4, that tells me that this is going to be a 1. Because what this is this becomes I to the 4th to the 9th power. I to the 4th is 1, 1 to the 9th is 1, so this becomes I. Okay? So now I'm going to look at this next one. So I times I to the 74th. Is 74 divisible by 4 evenly? The answer is no. Okay? So now what happens here is now I'm going to have a negative. So this is going to break up into -I. So the other way we could look at this is divide this by 2, right? So if if when I divide this by 2, it's an even number, then I know it's -1 to the even power, which is going to be positive. If it's an odd number here, like this is 37, -1 to the 37th is -1. So that's where I get that -I. So last thing we're going to talk about is conjugates and what conjugates do when we multiply. So what a conjugate is it's the negation of the imaginary part. So if I have a plus bi, my conjugate is going to be a minus bi. So if I had -2 minus 6i, my conjugate is -2 plus 6i. The nice thing about conjugates is when you multiply them, the imaginary portion is going to go away. So when I multiply this out, 5 times 5 is 25. 5 times -7i is -35i. 7 times 5i is positive 35i. And 7i times -7i is -49i squared. Well, if you notice here, this middle piece goes away, right? They cancel out. So I end up with 25 minus 49 times -1, which gives me 25 plus 49, which is 74. Okay? Well, this is a good thing to know about conjugates because remember, we want to be able to rationalize our denominator here. So because I is a square root, we don't want to leave a square root in our denominator. So when we're dividing, we're going to multiply by the conjugate. Because that's going to get that imaginary piece out of my denominator. Now, this is the nice thing because when we're dealing with conjugates of imaginary numbers, complex numbers, I can just, in my denominator, I can just square this value plus the square of this. So this becomes 1 squared plus 6 squared. Because you saw up here, I had 5 squared minus a -7 squared. So it becomes a positive. Okay. Now I'm just going to multiply this out. This gives me 2 plus 12i. Then I have -5i minus 30i squared. Okay. So on the bottom I get 1 plus 36. I know here that I have 2. This gives me 7i. This gives me plus 30. Now I have 32 plus 7i all over 37. Now, make sure when you're at the end here that you can't reduce this down. So if there's anything that goes into each piece there. So that's talking about complex numbers, understanding how to utilize conjugates in division, and then understanding that I to different powers reduces down to one of 4 things.